Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The starting material is methylcyclopentane, a cyclopentane ring with a methyl substituent. Moving on to the next step. Reaction 1, Br to HV, free radical bromination. Free radical bromination is highly selective and preferentially abstracts the most stable, most substituted weakest CH bond. In methylcyclopentane, the tertiary CH at the ring carbon bearing the methyl group is the weakest and most reactive. Therefore, bromine radical abstracts the tertiary hydrogen and Br adds to the tertiary carbon. Major product X is equal to 1 bromo 1 methylcyclopentane tertiary bromide. Moving on to the next step. Reaction 2, alcoholic KOH heat E2 elimination. Alcoholic KOH causes dehydrohalogenation E2. From 1 bromo 1 methylcyclopentane, elimination removes HBr. The Br is on a quaternary like tertiary carbon. Elimination occurs to give the more substituted alkene by Zaitsev's rule. The product is 1-methylcyclopentene, methyl group and double bond on the ring, endocyclic alkene. Major product Y is equal to 1-methylcyclopentene. And for the final step. Reaction 3, HBr peroxide, anti-Markovnikov addition. In the presence of peroxide, HBr adds via a free radical mechanism following anti-Markovnikov regioselectivity. The bromine radical adds to the less substituted carbon of the double bond, the terminal less substituted end. In 1-methylcyclopentene, the double bond is between C1, bearing methyl, and C2. Anti-Markovnikov addition means Br goes to C2, the less substituted carbon of the double bond, i.e., the carbon without the methyl group, and H goes to C1, the more substituted carbon bearing the methyl group. This gives 1-methyl-2-bromocyclopentane. Major product Z is equal to 1-methyl-2-bromocyclopentane. Stereochemistry note. Radical addition gives predominantly the more stable product. The major stereoisomer would be the trans-1-methyl-2-bromocyclopentane trans arrangement, consistent with option C. Why other options fail? A. Bromocyclohexane, no ring expansion occurs under these conditions. B. 1,3-dibromocyclopentane would require 2 bromination steps, not consistent with the reaction sequence. D. Cyclopentylmethyl bromide, bromomethyl cyclopentane. This would require Br to end up on the exocyclic methyl carbon, which is not consistent with anti-Markovnikov addition to 1-methylcyclopentene. The methyl is not part of the double bond in the endocyclic alkene. Therefore, the correct answer is C. Therefore, the correct answer is option C.